from today. We'll wait just a few minutes while our friends from all over the East Coast join in on our phone call today. We've got a lot of folks saying hello in the chat. Welcome, everybody. I see Sydney calling in from Montgomery, PA. Hey, Sydney. Ben, we see Delia. Hey, Delia. Welcome, everybody. I see Jordan. I see Adonis. We've got a whole big crew here today. Welcome, everybody. Welcome, Mason. Welcome, welcome, Arnav from Philly. I'm calling in from Philly too today. Welcome, Arnav. We see Izzy, Alyssa from Plymouth Meeting. Wow, we've got a whole big crowd here. I don't know if I'm going to be able to get through all of us today. We see the Newman kids, Timmy. We see Seneca and Lakota. Mia, welcome, Paul. Welcome, Nicholas, calling in from Lebanon, New Hampshire. No kidding. Calling in from New Hampshire. Welcome, welcome. We see Andrea, Alyssa. Let's see here. Avanish, Johan, welcome, everybody. Welcome, welcome. In just a minute, we'll get underway. If you're just joining us, you're joining in on the Biomedical Engineer activity. My name is Rachel. I'm a scientist at the Franklin Institute, and I'm so excited you're joining us here today. If you haven't had a chance yet, go ahead and say hello in the chat. Let us know who's joining. We've got a big crowd today. I love to be able to talk with everybody. And you'll notice you won't be able to see your video. That's okay. We're going to use the chat today to talk to one another. And let's make sure we keep it about science in the chat. We'll save all that other fun stuff for another time. And we can work our way through. I'm not sure I'm going to be able to get to everybody here, but let's try it. We have Levi from Drexel Hill, Ling Shi from Philly, Sarah from Chester Springs, Harvey. Welcome, everybody. We are ready to rock and roll. I'm so glad that you're joining us here today. Let's see here. Francesco, Wanli, I have to get through everybody. You know I do. I love that you're all joining me here today. Natalie, Mia, Yash, welcome Sophia, Celine, and Ezra. So as mentioned, we've got a big crowd today. Go ahead and continue interacting with me in the chat. We're gonna keep it in the chat today. Now you may know there may be some background noise on my end. Calling in from the museum today, so we've got some excited families joining us. So bear with me if you hear some sound in the background. All righty, I think we can move along on my back end today. My colleagues are going to help me move along my slides, so you're going to hear me talking to them. And so Andrea, I'll ask you please to go to our next slide to get us underway. As mentioned, we're calling in from the Philadelphia area and all up and down the East Coast. We even heard from some folks joining us from New Hampshire today, but we're just a few dozen of the hundreds of students that are joining in with the biomedical engineering activities this summer. We're really excited about this, and we're really proud of our program reach. Check out that map. Everywhere you see a red dot on that map, that's where students are joining in, students just like you, to be an engineer this summer. So we're a part of a really big engineering research team all across the country, coming up with some really, really cool solutions to some really, really hard problems. Andrea, if you could bring us to the next slide, please. Thank you so much. And as mentioned, we're here on the biomedical engineering research team. And I want to know, we've all done this activity already, so you're ahead of the game here. And so I've got a question for you. We've got a poll question that's going to pop up. If you're joining us on Zoom, you can go ahead and answer that. And if you're joining us via YouTube, hopefully you can join that in your own chats, answer that in your own chats with your research team. So let's go ahead and pop up that first biomedical engineering poll. We want to know, did the biomedical engineering activity make you more interested in being a scientist one day for your job? Looks like we can answer a lot, a little bit, or maybe not at all. Go ahead and tell me in the chat, and we'll wait just about 30 seconds or so for folks to get those answers in. Remember, if you're calling in from our live stream on YouTube, you can share that in your own chat with your educators and with your group in your own chat. So go ahead and answer that question, and I'll wait just a few seconds while you finish it up. While we're answering that, it looks like we've got some folks answering in the chat. We hear always a lot. Yeah, that's awesome. This is exciting to see. Only a little because I'm already interested. That's a really good answer too. All of our answers are right. And if our answer is not at all, that's okay too. Crystal says a lot. I love science. Cool. Crystal, I love science too. Thanks for sharing. We hear a lot. Natalie says they were already interested. Okay. Let's see what those poll results say. It looks like predominantly we said a lot. So it sounds like a lot of us are really, really excited, maybe about becoming a scientist one day for our jobs. Some of us are a little bit excited, and that's okay too. And some of us say not at all, and that's okay too. We want you to get a chance to get an understanding of what all those potential scientist jobs look like. So thanks very much to my team on the back end. We'll close down that poll. So we did the biomedical engineering activity. And as a part of this research team, we had to solve some really hard challenges having to do with biomedical engineering. But I want you to tell me in the chat, what did you learn that biomedical researchers actually do? What do biomedical engineers, actually do? Go ahead and tell me in the chat. What did you learn that biomedical engineers do? Yeah, we see one awesome response here. We say they help people with disabilities. Yeah, we learned about assistive technologies. Let's see, it says they make design tools. Where's my chat? Oh, my chat popped away. Let me pull that back up again. There we go, great. Mason says they create machines to help people. Yeah, Mason, great response. It says Sydney here, whoops, my chat's scrolling too quickly. We've got a lot of great answers coming in. Sydney says they make designs for new medical tools. Ling Shi says they help solve problems for people with disabilities. Mason, yeah, they help create machines that help people. Absolutely. Katrina says they care for people. Levi says they solve problems for medical problems. Biomedical engineer says help people with limited movement. It looks like we have a lot of agreement in the chat about what it is that biomedical engineers actually do in their careers. And predominantly, and that means mostly, we're seeing that folks recognize that, yeah, biomedical engineers ultimately help people. And the way that I like to define it is that biomedical engineers work on technologies that help improve people's health. We're seeing a lot of responses like that in the chat. Let's see, Celine says they buy the machines. Yeah, Celine, maybe they actually do purchase machines. Maybe they're helping create, but maybe they're just using the machines. Mia says, I learned they help people that have certain movement disability. Yeah, and we're gonna get a chance to talk about that together in just a moment. Marcy says, for people who have a hard time moving. Yeah, we learned a lot about different abilities during this activity, didn't we? We got to think about different engineering solutions to help those folks. All righty, I think we can probably move along then to our next slide. Thank you so much to my team on the back end for helping out with me today. So those were a lot of awesome responses that I saw in the chat. Thanks everybody for being so energetic. And let's keep that energy up as we move along. I want you to think back to the activity that we've actually all done together. You may recognize some of these photos, and they kind of look a lot like the responses that we were hearing in the chat about folks with limited movement abilities. And indeed, think back to this activity. We worked for a company that helps people with limited movement. And one of our customers had trouble moving their shoulders and their waist and their legs. And they asked us to help develop a tool that made it easier for them to reach and pick up papers from across their desk. That sounds like a pretty common problem, don't you think? Well, let's see what we found out in our research. I want to hear from all of you what you found out in your research. So you can rely on your memories. And if you have it handy, go ahead and pull out your lab notebook. I'm holding up there. You should be able to recognize that. There we go. Go ahead and pull out your lab activity notebook. And in there, you can reference your awesome answers. Again, if you don't have it, don't panic. You can share with us your thoughts in the chat without that notebook. All right. So first, if you remember in our activity, we measured how far a person could reach without being able, to bend over or raise their arms. And we thought about how that was different from when that person reached with their whole bodies, just like in these photos. On the left, we see the client is reaching for the paper on the desk using their whole body. It looks like they're moving forward at their waist, and maybe they're even scooching up using their legs. But we notice that the client on the right is reaching for the paper without using their shoulder, waist, or legs. Go ahead and tell me in the chat, and from your background research that you collected during your activity, what do you notice about these differences? Tell me what you notice about the differences between these two clients in the photos. Mason says, people with full movement can reach a foot farther than the people with limited movement. Mason, go ahead and tell me why you think it's a foot exactly. Is it a foot? Is it 6 inches? Is it 20 inches? Why did you say a foot? While Mason's answering that, let's see what others say. Nirmala says, the one on the right is closer to the table. Yeah, we agree, Nirmala. It looks like if we look closely at these photos, it looks like the client on the right has gotten very, very close to the table. Maybe they can't reach as far as the person on the left. Marcy says, one of them is using their whole body. Yeah, I agree, Marcy. It looks like the photo on the left is using a lot more body parts, right? The arm is extended, we can see. So we're using really good observations there. And Mason says they knew it was a foot because they measured. Yeah, great. Engineers, of course, are always using data they collect using different measurement tools. So in this case, our measurement tool was a ruler. Great job, Mason. Fred says one is hard. Say more about that. Say more about that. What is hard? And that was Francesco. One is hard. What do you mean by that, Francesco? Mia says it depends on the person. Okay. Mia, tell me what you mean. What depends on the person? Is it their reaching length? Is their ability? Tell me what you mean by it depends on the person. Arnav says one has limited movement. Juliet on the left. Juliet says on the left, she is blank than the one on the right. What do you mean by that, Juliet? Tell me more in the chat. These are really awesome answers, everybody. Thanks for being so energetic with me. Parvati says the people with full movement ability move much farther than the people with limited movement. Now, Parvati, it certainly looks to be the case that we can reach the paper on the desk from a further distance away, when we can bend at the waist and maybe even use our legs. Cool, let's see. Sydney says, limited to reach or stretch under 12 inches. Yeah, so maybe it sounds like, again, we have a measurement there. Julia says, I noticed that one can use their whole body, while the other one can't reach as far because they have limited movement. Yeah, it sounds like we have a lot of agreement in the chat, don't we, folks? It sounds like those folks that have a little bit more ability to bend and reach forward can reach farther. And that was that reaching length that we measured in our activity. All right, let's take one more comment before we actually ask some more questions about this. Mia says it depends on their range of movement, arm length, and the person. Yeah, so it sounds like when we're doing biomedical engineering, we need to do it specifically for our customers because people come in all shapes and sizes and abilities. All right, so I'll ask my team on the end here. Andrea, we can stop sharing those slides for just a moment. Let's get into some other questions about that activity. Now, beyond thinking about what the differences were between our two clients there, you also had to think about a tool that could assist our customer that had limited movement. I want you to tell me, what did you think that assistive tool needed to have? What did it need to do? What did it have to look like? Go ahead and tell me in the chat. And you had to design that reaching tool to help your customer. What did it have to do? And what did it need to look like? I know it's hard because we can't see in the chat pictures, although we wish we could, of course, but we have to use our words here. So Crystal says they had to create a grabber. Yeah. Elise says it needed to grab and be accessible. Ling-Shi says it needed to be easy to use. Yeah, great observation, Ling-Shi. These are all awesome comments, folks. Marcy says something to grab, and mine looks like a hand. Cool, Marcy. Looks like a hand. Levi says it needed some length to be able to grab. Seneca, yeah, says grab paper without using your shoulder. In our description of the activity, we learned that our customer couldn't use their shoulder. They couldn't really reach out as far as they wanted to. Some other folks say, let's see here. Celine says they created a grabber. Lots of answers in the chat here. Elise says it had to be clear what you needed to do to activate it. Elise, I love that comment there. So it had to be kind of simple to use, simple to understand, right? We don't want it to be more difficult for our customers, certainly. I like that thought a lot. So a lot of folks are saying it needed to be easy to grab. Arnav Parvati says that. Ben says it needed to reach far. Yeah. Sydney says my reaching tool had to be at least 12 inches long with a pincher. Had to be easy to use and have movement. Yeah, so it sounds like a lot of us are agreeing in the chat. It had to be easy to use, had to be able to pick something up. Next, you had to think about how long the reaching tool had to be. And it sounds like a lot of us in the chat are saying that it had to reach far. And we've had some folks even say it had to be about 12 inches. How did you get that measurement? Kind of talked about this earlier, but I want to know, get in the chat. Go ahead and tell me, did you need your tool to be a particular size? Did you need your tool to be a particular size? Yeah, Parvati says my grabber needed to be long and lengthy, so the client could use it for long distances. Yeah, all righty. Crystal says their tool needed to be adjustable. Needed to be adjustable. Marcy says to fit a hand or an arm size. Elise says their tool was about the width of a large table. Katrina says our tool needs to help someone reach, and it needs to be able to pick up objects and bring it to the person. Yeah, Katrina, great observation. Mason says it was about an arm length. Yeah, and Mason also commented earlier that that was roughly a foot. So I'm guessing, Mason, that your arm is roughly a foot. So my arm is a little bit longer. So when I had to measure my tool, I had to measure a foot and then another foot because I have longer arms. And I'm hearing a lot of awesome observations in the chat that are saying, yeah, these tools needed to change their size depending on the person using them. Depending on the person. Okay. So we could chat, I'm sure, for hours here about all of the various tools that you built. And I want to continue hearing about the tools that you built and the shapes and sizes that you use. But I have also been working on my own tool, and I really need your help to help perfect it. So what I'm going to do is I'm going to switch my camera view here, and I'm going to pull up my tools that I've been working on. And while I'm switching my camera, go ahead and keep using the chat, and maybe tell me a little bit more about the shape of the tool you made. Go ahead and tell me in the chat the shape of the tool that you made, and I'm going to switch my camera while you're doing that. Okay, so we've switched cameras here, and hopefully you can hear me just fine. I've got a couple tools that I've put together, and I'd like to talk through the shapes that I've made. I hear in the chat some folks made diamonds with X's. That sounds really, really cool, Seneca. Crystal says it was long and wide. Pratima says it looked like a stick. Arnav said it looked like an X, so it sounds like the X might have been a popular design. So go ahead and keep telling me about those shapes, and let's take a peek at the shapes that I made. I have two grabber tools that I brought along with me here today. And one of them kind of looks like a stick, right? We heard a couple of you folks in the chat here say that yours looked like a stick. And yeah, it's not all that exciting looking, is it? I took some popsicle sticks here and I taped them together. And what's hard to see on the camera is that the top two popsicle sticks here open and close, almost like tongs. I think it kind of looks like barbecue tongs or tweezers, right? So you can sort of see an open and close there. So that was one model that I tried out. Another model I tried out, I'm calling this one my pizza pan model. Kind of looks like a pizza pan or maybe a fly swatter. So this one's a lot longer than my other model here. And you'll notice it's a little bit more complex. So I've got sort of the same setup on the base here to make it look long, but the front of it almost looks like a shovel or like a fly swatter or a pizza pan. So I've got some sticks here in the middle, and I'm going to try to turn this on its edge. And if you look really, really closely, let's do this angle. You can see that these two pieces open and close. They open and close. So why do you think I made these two tools to have the sticks that open and close on the end there? Go ahead and tell me in the chat. Why do you think I designed both of my tools to have sort of an open and closed model on the end of them? What are our thoughts there? Yeah, a lot of us are agreeing here in the chat. Elise, Crystal, Delia, we're all saying it's to grab and grip the paper, right? Elise, Manya says, Marcy says, yeah, looks like we have overwhelming agreement. That's why we designed it that way. So go ahead and tell me in the chat, of my two models here, let's call this one my stick model, and let's call this one my pizza pan model. Which one do you think, based on your own research, is going to help pick up the paper better? Why, or rather, which of these two models do you think will better help pick the paper? Yeah, overwhelmingly, I'm hearing folks say it's the pizza pan model. And is it because you just love pizza? Delia says pizza is the best. I agree, Delia. I love pizza too. But tell me why. Why is the pizza pan model? Why do you think the pizza pan model is going to be better? And we can test out our thoughts here. So go ahead and tell me, why is the pizza pan model going to be better? Why do you think? So Levi says that the pizza pan might have more grip area. That's a really interesting thought, Levi. Lucas says the pan is the same shape of the paper. Interesting, Lucas. So maybe the shape of my grabber compared to the shape of the material I want to pick up is important. That's a really interesting thought. Then she says, I think it's better because it's bigger. All right, so maybe the size of the tool is going to be really, really helpful. Parvati says the pizza pan grabber is wide and long. Okay, so we're hearing a lot about the necessity or the need to have a tool that is bigger, maybe. Maybe the bigger the grip area. Yeah. Manya says, I personally think the pizza pan will work because it looks stronger and it can hold more things. Yeah, strength was a really important consideration here. We wanted to make sure that our tool could pick up the paper and hang on to the paper, right? You don't want it to fall over, essentially. That's great. Juliet says the stick is too short. That could be the case. Well, let's try it out, y'all. We can actually test all of our thoughts here. And what we can do is we can actually go ahead and attempt to improve. So I think we like the pizza pan model. So I'm going to go ahead and I'm going to put my stick model to the side to hang out maybe for later. And I've got a little piece of paper here. We can actually model how easy or difficult it is to pick up, or rather we can test how easy or difficult it is to pick up my piece of paper. So I've got all my materials here, and I push them off to the side so they don't get in the way of our camera view here. We're going to give it a go. You ready? So let's try first with the pizza pan model. So I've got my paper here down. Let's turn it this way so you can see it nice and easily. And I'm going to go ahead and I'm going to try the pizza pan model. So here we go. Folks are saying it needs to be longer. Yeah, you can't really see my whole arm length here. And I'm kind of pushing it, but what do you see happening as I'm pushing the tool against my paper here? Let's try that again. Maybe you can see that from another angle. What's kind of happening as I'm pushing my pizza pan model into the paper? Yeah. Delia says it's pushing away. Yeah, Elise says it's sliding away. Let's go one more time. Right? Well, that's kind of a bummer. That doesn't seem to be helping very much. Delia says, yeah, it's not grabbing. All right, it's going away from me. Yeah, that's a really big challenge. Did anybody else run into this challenge? Let's see if I can use my second tool as well. Yeah, Mason says they ran into that challenge too. Maybe not. You might have come across one direction. Yeah, Mia says flip it over and use it to pull. All right, Mia. So Mia's suggestion here, I love that engineering idea there. We failed on one attempt, but let's try another way. Mia says put it on and pull. There's a cool way to do it. All right, so maybe pulling is a great idea. Lucas says it needs to be angled like a shovel. Yeah, maybe I need to actually adjust how. Let's see if you guys can see me changing the angle. Yeah, lifting up and down that pizza pan tool. Maybe I can fix it that way. Maybe I can try that. Oh, that seemed to help there. All right, Lucas, that was a great suggestion. That kind of flops over to the side, doesn't it? Juliet says, put the pan on top of the paper and pull. Yeah, Juliet, we heard that suggestion. I think it's a great one. Flip it over and pull. That's kind of one solution. I really like these solutions, y'all. Levi says it needs to be able to open like a clip. Yeah, so we heard earlier that the opening and closing motion of my pizza pan tool is really important. So maybe I need to give it a little help. Maybe I need to open it to start with, to push under. Let's see. That kind of helps, didn't it? I like that solution. But then I get kind of sticky on the end. Yeah, Autumn, good observation. It is pushing the paper away. Alrighty, so maybe I had some solutions with my pizza pan here. And I really like those suggestions to actually try and put it on top and pull. I think that's a really creative solution, engineers. That's a great suggestion. We also heard a couple other techniques that worked. We opened up the bottom portion here and we kind of helped it out a little bit before we tried to pick up the paper, right? But then it's kind of falling off there. So still some challenges, but we definitely made some progress. Let's try our other tool here. So we tried our pizza pan, but now I've got my simple little stick model, and similarly, it's got this open and close portion here. So let's see if this one works out. So we thought our pizza pan model was going to be better, but let's see if our stick model works out. So let me try here. Well, what do you notice as I try and pick up the paper using the stick here? Katrina says, boo. Yeah, maybe it's having some trouble picking up the paper. Yeah, Marcy, it goes right over. What are others observing when I try to pick up the paper with the stick model? Yeah, some folks are saying it looks like it's going right over the top. Yeah, indeed, I'm having that challenge here. So once again, I'm having trouble getting under the paper. Lucas, yeah, absolutely. You can't lift the paper. Yash says, try turning it over. Yash, I love that suggestion. Let's go ahead and flip it and see what happens now. All right. Well, it looks like I'm able to move the paper now, but I'm still having trouble picking it up. So what's one solution we might consider here? Whoa, Delia says use the stick and the pizza pan like chopsticks. That's a really cool suggestion, Delia. We also hear from Parvati and Ben to try angling. So we heard that solution earlier too. So it worked for our pizza pan. Let's see if it works for this piece of paper. So instead of coming flat, let's see if I can come from an angle. Yeah, so that worked for our pizza pan, but not really working for this one, is it? Let's try some other solutions we heard. Let's try that chopstick idea. So we'll go with our pizza pan. Now we're getting crazy here. We got two hands in action. Let's see if we can handle it all. One pizza pan and one stick. Maybe we can sort of push them together somehow. Kind of like this. Yeah, I think that's a really cool suggestion, Delia. But my paper kind of rolls up, doesn't it? So do you think could we continue improving? Is our chopstick way the best way? How might we best improve this model? What do you guys think? If I were to use two tools here, how could we do that the best way? And while you're answering that in the chat, I'm going to go ahead and switch my camera back. How could we better improve that technique using the two tools? Let's see here. Autumn says, yay, yeah. Ben says, cool, it worked out. Yeah, using two tools was a really new solution. Erin suggested putting tape on the ends so stick to the paper. Yeah, that sounds like a really creative solution, Erin. Elise says sharpen the edges so it goes under the paper better. I like that solution a lot, Elise. These are really creative solutions. Crystal says put the stick at the back and then use the spatula to pick it up. Yeah, kind of the same idea. So like coming at it like this almost with two tools. Levi says put the stick and pizza pan together somehow. Yeah, so maybe Levi, we'd want to combine those two things permanently. Maybe we could use tape or some of the string that we received. Juan says make it like a tweezer. Yeah, so we want to improve the model so that it's better grabbing the material. Okay, y'all. I think these are some really creative solutions, engineers, and I could be here all day improving them. So it sounds like I've still got a lot of work to do on this tool, but I really appreciate all of your suggestions. And you've given me some really, really cool ideas. And something I want to share with you, if my friend Andrea could turn my slides back on here, is that what we just did there all together in our engineering research team is something that biomedical engineers and all engineers do all the time. And it's that we try and try again. And sometimes it can be frustrating, right? Especially if our problem is kind of tricky to figure out. It's really important that we try and try again. So we researched the problem, we thought up a solution, we tested our solution, and then we maybe changed that solution. So I want to know, when you changed your solution, when you changed your tool, what did you do to change it? And maybe actually let's start with how many times you changed it. So go ahead and tell me in the chat, how many different ideas did you try for improving your grabber tool? How many different times? Marcy says 3. Parvati says 3 to 4. Ezra and Audra say 2. Lingxi says 2. Yeah, it sounds like a couple of us maybe got there within just a handful of times. 2, 3, 4 seems to be sort of the average. An says 1. Maybe An got it right on the first time or got it right for their particular setup. Levi just says a lot. Yeah, Levi, sounds like I could be doing a lot also here. And we learned that it sounds like you folks came up with dozens of solutions. I only had 2 tools with me here, and we, in just 10 minutes, thought up about 5, 6 different ways to use just those 2 tools that I had there. Elizabeth says 6 times. Sunny says 3. Yeah, so it looks like generally we all took a handful of times to try different designs. Okay. So Andrea, you can leave it on that slide there, just to remind us that we do try and try again. So it sounds like we're having some slides change around. No problem there. Autumn said 0 times. Maybe Autumn didn't give it a go. Well, there's plenty of time, Autumn, to give that a go now. Francesco says, after we made a mistake, we learned that the idea does not work. Yeah, I really like that comment. Now I have another question for all of you. Of the designs that you made, what was a part that worked really, really well? Of all the different designs that you made, what characterized what worked? Let's see, Delia says, yeah, elimination. So maybe you went through a whole bunch of solutions. Mia says, tape, exclamation, exclamation, exclamation. So tape happened to be particularly helpful in this activity. Crystal says the grabber was the most important part that helped them make their tool work. Delia also says in caps, tape, tape, tape. So it sounds like a lot of us were relying on tape. Marie says the popsicle sticks were the most useful part. Cynthia says putting the 2 together. Yeah, so maybe using a couple different materials or a couple different types of tools together. Levi says they love tape. Yeah, in this activity, tape was our best friend, wasn't it? An used tape, rubber bands, and cardboard. I love that solution. So An used materials that didn't come in the kit. They came up with their own material solution. And that's exactly what engineers do. When we try and try again, we look to all different approaches. Some of us use hot glue and cardboard. That was Marcy. Mason says tape and paint stirrers. Now Marcy also tried to use string for their activity. Elise, wow, Elise has used popsicle sticks and pieces of wood and tape. So lots of different materials. Julia says they use something like a fishing pole with tape at the end. Sticky stuff. Yeah, so it sounds like a few of us tried using sticky stuff to hang onto that paper. I think that's a really, really cool suggestion. Natalie says they used silly putty, exclamation, exclamation. Yeah, Natalie, silly putty can be sticky. So it sounds like a lot of us liked to use the sticky stuff. Awesome. These are really, really cool findings. Thanks everybody for your research. We definitely have lots of good ideas to make an improved reaching tool for our patient. What I'd like to think about is a real life biomedical engineer. So we've been trying our hand at biomedical engineering today, and it's really, really cool to note that biomedical engineers can come from all over the world They can come in all shapes and sizes. They can research at all kinds of different locations. And I've been learning about a really, really interesting biomedical engineer at the University of Pennsylvania. So those of us that are calling in from Pennsylvania today, this university is located just in Philadelphia. So you might know of Dr. Michelle Johnson. And she has a really, really cool personal story. So Dr. Michelle Johnson was actually inspired by robots and technology because of Star Wars. So she got interested in engineering because of Star Wars. Does anybody know about Star Wars out there? Is anybody interested in the really cool technology that's in films like Star Wars? I'm seeing a lot of big yeses in the comments. We love Star Wars. I love Star Wars too. Well, if you know Star Wars, you might know about R2-D2. And R2-D2 is a robot that inspired Dr. Michelle Johnson. So she got into engineering because of a film like Star Wars. So maybe some of us would be interested in pursuing engineering because of activities like this and other inspiration from science fiction. And we say, may the force be with you, we see in the chat. Awesome, folks. So Dr. Michelle Johnson was interested in technology and robotics, again, because of science fiction like Star Wars. And she was also inspired by a really personal, tragic story when her grandmother had a stroke. She was studying robotics and her grandmother got sick. And her grandmother, after she had a stroke, had limited mobility, very similar to the clients that we worked for in our activity today. And this inspired her to help develop robots to help people recover after big moments of sickness, to help them recover and to help strengthen their muscles after accidents, stuff like strokes. So she now builds robots to help patients practice different arm movements, like lifting a coffee cup. She also works on robots that can play games, kind of like Simon Says, and that helps making it fun. Make it fun. And you can see in that photo on the right side, she's raising her hand to one of her robot creations, and they're mimicking one another. She's actually playing a game with this robot. And this robot, in turn, can help assist folks that are recovering from big accidents or maybe even strokes. And again, I love Dr. Michelle Johnson's story, not just because I love Star Wars, not just because you all love Star Wars, it looks like in our chat, but because it tells us that we need all kinds of different people with all kinds of different skill sets and interests to help us solve engineering problems. And if you're not interested in engineering now, kind of similarly to Dr. Michelle Johnson, you might find your inspiration elsewhere, maybe via a personal interest or a personal story. You can learn more about Dr. Michelle Johnson at her YouTube link. We sent a link out in the chat there. You can listen to her whole story about why she's inspired by certainly Star Wars, but also her grandmother's own story. All right, so we can go to the next slide, please, Ms. Andrea. I've got another question for you folks. This time, I want to know, how did you think or act like a scientist while you were doing these activities? And that can be based on today's exercise or based on when you did the exercise before today's call. How did you think or act like a scientist when doing your Be a Biomedical Engineer activity? And you'll notice that some of the answers in there might be familiar to you. And that's because we pulled them right from the sticker sheet that came in your activity, or you may have printed this off. So you'll notice that maybe you had fun. Maybe you had an idea, and I think some of us did. I heard that in the chat. Maybe you made observations. Maybe you tried again or asked a question. Now notice that you can click a bunch of those boxes. You can click as many as apply to you. And if you don't have that window, go ahead and tell me in the chat, how did you think or act like a scientist? And while we're collecting those, let me take a peek at our chat. Mia says all of them. Yeah, Mia, it sounds like you were really engaged with these activities. Erin says everything. Delia says every single one of them. I say all of them. Ann says every single one. Elish said, I didn't do the project, but I asked my mom for help. Elish, I love that comment. It takes a lot of help to find good engineering solutions. And as biomedical engineers, we have to ask our friends and our peers and our colleagues about how they're solving problems. Asking for help is a really big part of being a biomedical engineer and being any kind of scientist. All right, let's go ahead and check out those poll responses. Wow, looks like we've got a lot of responses in the poll. Thanks everybody for engaging with us. Looks like a lot of us observed. Most of us said we try again. That is my favorite thing about being a scientist, that we get to make mistakes. And no wonder, we take on really hard problems. And so we have to try again to find the right way to solve the problem. And sometimes those problems can be tricky and they can hide themselves from us. But by asking questions and trying again, we can find a good solution together. Looks like a lot of us answered that they observed, tested, tried again, asked a question, had an idea, learned something new, worked together, and had fun. So that's really exciting to see everybody. We've got one more poll after this. I want to make sure that we have time to ask this question too. I want to know if this biomedical engineering activity showed you that you can do science. All right, and these answers are kind of like our first question. It's like you can do a lot, a little bit, or not at all. And that's okay too. And if you don't have that poll pop up, go ahead and tell me in the chat. Did the biomedical engineering activity show you that you can do science? Take up my chat here again, and it looks like Delia says a lot, always a lot. So Delia's excited about this. Arnav looks excited too and says a lot. Levi said, I did not at all because I sense all the time. I do them maybe all the time. So maybe it sounds, Levi, like you're doing a lot of these activities. And so each individual one might not be that important, but maybe you're interested in all of them. And that's okay. Angela says definitely a lot. Hans says a lot. That's exciting to hear. Thanks everybody for sharing in the chat. Let's give it just another second and take a look at those poll results. So it looks like most of us said that doing the activity showed us that we can do science a lot. Some of us said just a little bit. Some of us said not at all. And that's okay too. All right, let's move along to our last couple slides here. Thanks everybody for helping me answer all of those questions. We've got just 2 minutes left. If we could go to the next, yes, there's that slide. Thank you, Andrea. So we did our biomedical engineering activity today, but those of us that have been following along with the GSK program know that we've actually got 4 different activities this summer. So we're going to share a link in the chat, and you can check out our Be an Engineer website. Alrighty, so those are going to live on there. Go ahead and go on. You may need a parent or guardian to help you navigate that website. But go ahead and check out those different activities. In addition to the Be a Biomedical Engineer, you can choose to be an electrical engineer, an environmental engineer, or a structural engineer, and take on all kinds of different problems. And as we're closing down here, I'll just share one kind reminder to our live stream educators that are joining the call today. So we asked those poll questions today here on Zoom, but if you're joining via live stream, go ahead and ask those poll questions of your students, tally up those answers, and you can upload those results. And that does it for us today, engineers. I want to thank you so much for your energy, your enthusiasm in the chat. I know it's hard when we can't be on video and audio together, but I think we used this chat perfectly today. I had a lot of fun working with you today, and I hope you did too. This is the best research team out there, I can tell. Thanks to our project sponsor, GSK. From all of us here on the Science in the Summer team, we hope we get to see you again at another Be an Engineer event. Thanks, everybody. I see lots of thanks in the chat. Thank you, everybody out there. And I will hang on in case you have any last questions. Thanks, everybody. Bye now. And it seems like we've got lots of folks in the chat. Thank you, everybody. Bye, Yash. Bye, Erin. Thanks for joining us. Thanks, Delia. Thanks to Juan. Thanks to Angela, Natalie, Mason. Bye, everybody.